We're going to talk about exponent rules and how to add, subtract, multiply, divide a whole bunch of terms if they have an exponent. Now, the first thing you're going to need to do is be able to add and subtract exponents. Now, if you remember when we talked about adding and subtracting before, basically we're going to be counting how many of each term that we have. Now, when you add and subtract, you cannot make new things. Your exponents have to match in order to combine your terms. So if we had x squared plus a 3x squared plus an x to the third power, the only thing you could put together would be your x squared and your 3x squared. This gives you a total of 4x squareds. Now the x cubed is a single term that cannot be combined together with anything, so it's just going to hang out with your 4x squared. Now when we change that plus sign into a multiply sign, we change how to do the problem just a little bit. Now what this is saying is you have 3 x's and you have another 2 x's. They're not being added together. We are multiplying, which means we can make new things. Now if you have 3 x's and 2 more x's, you end up with 5 x's. And all you have to do when you're looking at your 3 and your 2 is you add. So whenever you're multiplying terms with your exponents, you just need to add the exponents together. And you're going to leave this base the same. That's the shortest way to do this. So what you need to do is remember, if you're multiplying, you need to add the exponents. When you divide, if you add to multiply, you're going to divide by subtracting your exponents. If we break x cubed divided by x squared down, we end up with 3 x's at the top and 2 x's at the bottom. When you reduce all of your x's together, because anytime I have the same thing at the top and the bottom, I just end up with a 1. Everything at the top goes away, so the only thing I have is a single x. And if you do the same problem and you subtract the exponents, it should give you the same base, and all you'd have to do is say 3 minus 2. It still gives you an x to the first power. Now the next rule is called a power of powers rule. And this is different from the multiplying because we're going to have different bases when we multiply. And this is the same base when we have the power of powers. What this is saying is that I have 3 x squareds. You'll notice there's no more parentheses. It's just saying 3x squareds. And then you go back and you need to multiply all these. We'd end up with 2x, 2x, and 2x gives me a total of 6 x's. Now, shortcut, if you have a single base that has exponents that need to be shared, this is where you multiply them together. Because I have a set of 3 x squareds. Now, in this section, we're going to learn about negative exponents. When we first looked at example number 2, we ended up with an x cubed over an x squared. Now, we can subtract these exponents just like we did the last time, only you get x to the 2 minus 3 power, which gives me an x to the negative 1 power. If we do the same problem by breaking down our x's again, we end up with 2 x's at the top, 3 x's at the bottom. Then when you go to reduce, you get 2 x's that are going to reduce. And the only thing I have left is that 1 from here and the 1 from here. So your answer is going to be 1 over, and I have a single x at the bottom. So it's 1 over x. Now, these are the same problem. They should be the exact same thing. This is a different way to write 1 over x. If you don't want a fraction, you can just tell everybody, I got 1x, but it's a negative, so it's supposed to be at the bottom. And the way I always remember these is negative exponents are like negative people. They are very unhappy. And you've all met really unhappy people. They don't like anywhere that they are. So when you have an exponent that's unhappy, that's at the top, just move it to the bottom and it'll be happy again. Same thing goes if it's at the bottom and negative. You just have to move it back to the top. An example of this. Over x to the negative fourth. This is an unhappy x to the fourth, so it's going to go to the top and become a positive. Now the last exponent rule is called, we have powers of 0. Now if we have a fraction with an x cubed divided by an x cubed, we already talked about dividing. All you have to do is subtract your exponents, so you end up with an x and a 3 minus 3. When you subtract 3 minus 3, you get 0. Now if we break this up again, same problem. We have 3 x's at the top and 3 x's at the bottom. Okay. A set of x's goes away and I'm left with my 1's. Oops, sorry about that. Second set of x's and the third set of x's. The only thing left at the top is the number 1. Only thing left at the bottom is the number 1. So all of those x's go away and they just turn into the number 1. This is the same problem again. What that means is that x to the 0 power is going to be the number 1. Now this works for everything. I don't care what you raise to the 0 power. It's always going to cancel with itself. So anything to the 0 power is going to be the number 1. The base goes away, the exponents goes away, it just turns into a number 1. Take a look at some of these problems. Now number 1, if you have the quantity of 3a squared times b to the negative 2, c to the 4th, and it's being multiplied times a negative 8a to the negative 3, b to the 4th, and c to the 4th. It looks really scary, but it is not. We're basically going to do our order of operations. Now, you have to have two things that are being multiplied in order to take care of this. So, and another one. The first step that you're going to take is we need to get rid of the parentheses. Now, the only reason the parentheses are there is that negative in front of the 8. Now, you got to remember that that's really a negative 1 times an 8. And all I do is I move your negatives to the front, and no matter what, this is going to be negative 1, and it can always go in the front of whatever my answer is. You'll hear me say this all the time. I want you to get rid of all the negative exponents, which means you need to make everybody happy. So I start with big fraction. If something has a positive exponent, it stays where it is. So that 3 stays at the top. The a squared stays at the top. This b to the negative 2 is a happy b squared at the bottom. C to the 4th stays. 8 stays. The a to the 3rd needs to move to the bottom. B to the 4th stays. And c to the 4th stays. The next step we're going to do now is now you're going to combine things that are the same. Here, I'm going to move that. Oops. Move this down just a little bit. Now, when you're simplifying all this stuff, I don't necessarily use the negative rule. I just combine stuff that's the same. Now, this 3 has nothing to reduce with at the bottom, so I leave it alone. Now, if I have 2 a's at the top of this expression and 3 a's at the bottom, I'm going to end up with a single a at the bottom. If I have 4 c's and another 4 c's here, I'm going to have a total of 8 c's. Then if I have 4 b's at the top, 2 b's at the bottom, I end up with 2 b's at the top. Now the 8 and the 3 are just going to stay exactly where they are. So when I rewrite this with a negative, then a 3 and an 8 become a 24. I have 8 C's and 2 B's. The only thing I have left at the bottom, since that B reduced, is I have a single A. That's as simple as I can make that. So there's the answer. All right, in example number 2, we've already got things set up with a top and a bottom on our fraction. So we don't have to get rid of any parentheses because it's already done. We don't have to make any exponents positive because that's already done. So all we're going to do is simplify. Now, if we have a 3 at the top and a 9 at the bottom, this looks scary because they're sitting right next to each other. That did not work. Okay, let's try this again. There we go. If you just had a 3 over 9, you just reduce that to a 1/2 or 1/3. That's all you need to do is ignore the rest of this. Now this 3 is going to reduce and leave me with a 1. The 9 reduces and leaves me with a 3. Then M's have 3 at the top, 2 at the bottom, so they'll reduce. So I'm left with a 1 at the bottom and an M at the top. These end of the fifths, I've got 5 at the bottom, 5 at the top, so I'm just left with my 1's. Then I have 4 P's at the top, 7 at the bottom, so I'm left with 3 of them at the bottom. And once you do that, all you have to do is write down everything that's left over. We have 1 times M times 1 at the top, so it's just M. Then 3 times P cubed goes at the bottom. All right, that does it for our video on exponent examples. We'll go ahead and go over a whole bunch of other problems tomorrow in class. There you go.